Scatter plots and trend lines. Our objective is to create and interpret scatter plots, as well as use trend lines to make predictions. Who uses this? Ecologists can use scatter plots to help them analyze data about endangered species, such as ocelots. Let's start with some vocabulary. A scatter plot is a graph with points plotted to show a possible relationship between two sets of data. A correlation describes a relationship between two sets of data. So if we have a positive correlation, the data is going to be increasing. If it's a negative correlation, the general direction of the data is going to be in a decreasing pattern. If there is no correlation, that means the data is all over the place. So it's not going to be positive or negative. Let's start with drawing a scatter plot, or graph a scatter plot from a given set of data. So the table shows the number of species added to the list of endangered and threatened species in the United States during the given years. Graph a scatter plot using the given data. So your calendar year will be across your x-axis, and the number of species will be across your y-axis. So therefore, you'll plot a point. So at 1996, you'll plot a point at 91. And there is your scatter plot. Alright, so now let's try analyzing a scatter plot in terms of a negative or positive correlation. Alright, so we have watching TV, so TV, watching, and test scores. So as a student or as a person watches more TV in terms of hours, test scores appear to be going down. So since the graph is decreasing, it is going to be a negative correlation. In B, as the years progress, more participants are participating in snowboarding. So the graph is increasing. And since it's increasing, it's going to be a positive correlation. Alright, so now let's try identifying correlations. So identify the correlation you would expect to see between each pair of data sets. So let's try the first one. The number of empty seats in a classroom and the number of students seated in the class. Well, you would expect to see a negative correlation. As the number of students increases, the number of empty seats decreases. Alright, so now let's look at B. The number of pets a person owns and the number of books that a person read last year. These two pieces of information have nothing to do with each other. Therefore, there should not be a correlation. So you would expect to see no pattern in the data. Alright, so now let's look at C. The monthly rainfall and the depth of water in a reservoir. So as the month goes on, the depth of water is going to grow with more rainfall. So you should see a positive correlation. Alright, now let's try matching a scatter plot to a situation. So we're going to try to choose the scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant. So this first graph is saying that on day 0, the sunflower was 70 inches tall. Then in 20 days, it was 65, and then in 30 days, it was back up to 70, and by day 60, it was down closer to 50. A sunflower doesn't change in terms of decreasing value, nor does day 0 is your sunflower going to be 70 inches tall. So it's not graph A. Let's look at graph B. So at day negative 20, you've already made it so that it's not going to work. You can't have negative days for a sunflower seed. So at negative 20, it doesn't even make any sense. So it's not graph B. All right, let's just make sure it's graph C. So at day 0, it hasn't grown yet. At day 10, it still hasn't grown. And then at day 20, we're at about 5 inches. At day 40, we're just below 20. At day 70, we're almost to 50 inches. So it's slowly increasing in height. So it's going to be graph C. Take a moment and pause the video and try this next one on your own. Okay, so now that you've had a chance to try it, let's see how close we got. So choose the scatter plot that best represents the relationship between the number of minutes since a pie had been taken out of the oven and the temperature of the oven. So if we look at negatives first to try to just get rid of anything that has a negative value, well, the only ones that have negative values is graph B. So therefore, we can already just chop that out. We know it can't be that one. Okay, so now let's look at graph A and C. So in graph C, since the pie had been taken out of the oven, now mind you, when you take a pie out of the oven, chances are you turn the oven off. So if you look at graph C, after you took the pie out of the oven temperature is increasing. So that's probably not going to be the case either. And if we look at A, after you've taken the pie out, the pie was probably cooking at a little over 280 degrees. And once the oven was turned off, the temperature starts to decrease. So therefore, the only plausible one is graph A. Let's look at a fundraising application. This scatter plot shows a relationship between the total amount of money collected and the total number of rolls of wrapping paper sold as a school fundraiser. Based on this relationship, predict how much money will be collected when 175 rolls have been sold. So let's draw a trend line to help us make this prediction. So our trend line, now when you make a trend line, it's not going to be able to go through every single point nice and even. You want to just try to go through the majority of the data as best you can. And we want to look at 175 rolls. So at 175 rolls, the money raised is about $1,200. And that ends our lesson on scatter plots and trend lines.